Hello, 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 my dear friends. Anyone is in live? Hello, good evening, good evening. Still anyone is in live? If anyone is in live, just say me hi. If anyone is in live, just say me hi. Good evening, everyone. Good evening, good evening. Right now, we'll start the question session one by one. Now, for the each question, I will give you good evening, everyone. Good evening. For the each question, I will give you 1 minute, but within the 1 minute, try to complete the question. And if you are trying, just say me, sir, I was trying. Okay, sir, I'm trying. Just if you say me, so that I can hold. Right? Done. Now we'll go with the first question. Read the question carefully. Don't be in a hurry to give the answer because this is a calculation part. And check the calculation part also. And don't use any for the calculation purpose. Don't use any calculator and all. And if you don't know the question, just give me the question mark. I am ready to explain. But don't search in any Google or any chat GPT. This is not any what to say, this is not any praising section, right? If you know the answer, genuinely you give. If not, you give me. If not, you give me the question mark. I am ready to explain. Okay, right. Now we'll go with the first question. Now see the question. I hope the video and audio is clear for everyone. I hope the video and audio is clear for the everyone. If the video and audio is clear, just say me yes. For everyone, if the video and audio is clear or not, just say me whether the video and audio is clear. Now, yes, run. Done. Now see the question. Yes, okay. See the question. The aqueous solution of HCl with pH 1 is diluted by equal volume of water. Ignore the dissociation of water. The pH of the HCl solution would be. The pH of the HCl solution would be. Okay, fine. Good. pH of the HCl solution would be. Now, what is the answer? What is the answer? Are you trying or not? What is the answer? Should I explain or are you trying? Right. Now listen. Here, what he have given in aqueous solution, one pH is there, right? What is that pH formula? pH is equal to minus log of H plus ion concentration of its normality and the log, it is the base 10. Done. Now pH is the one, right? Then pH is the one means H plus ion concentration of that HCl will be the 10 to the power minus 1, because if you shift the log to the left hand side, because pH is the 1 and it will become 10 to the power minus 1. Then when we have added the equal volume of water, then what happens? Concentration will become half. So when we have added the volume of the water, what it will happen? Good evening everyone. Its concentration will become half. Then H plus ion concentration, when we have added the water, its concentration will become 5 into 10 to the power minus 2. Right? Now after adding the water, the H plus ion concentration has become 5 into 10 to the power minus 2. Then for this one he is asking what is the pH. Then we know the pH formula, right? pH is equal to minus log of H plus ion concentration. The H plus ion concentration we got, it is minus log of 5 into 10 to the power minus 2. We know, right? If any H plus ion concentration, it is in the form of x into 10 to the power minus y, then it will become, then its pH will be minus log x, right? Then pH will be equal to 2 minus log 5. Log 5 value will be the, how much? Log 5 value will be 0.7. 0.7, 2 minus 0.7 will be the 1.3. So the pH increases to 1.3. Option A is correct. pH increases to 1.3. I hope it is clear. I hope it is clear. I hope it is clear for everyone. Whenever we have added the equal volume or volume of the water, what it will happen? Concentration will become half. Right. Now next question. Then yes sir, right. Okay, fine. Done. Now next question. The pH of the water is 7 at 25 degrees Celsius. If the water is heated to 80 degrees Celsius, its pH will be. Its pH will be. Its pH will be. Answer is C. Answer is C. pH will be increases. Once again you cross check. pH will be, now pH will be decreases. It is not increases. My dear friends, we know experimentally Kw value will be 10 to the power minus 14 molar square at a 25 degrees Celsius. Right? Now Kw will be depends upon temperature. Kw will be depends upon the temperature. As we increase the temperature, what happened? Kw value will also increase. Kw value also increase. Let's suppose now Kw at 25 degrees Celsius, if it is 10 to the power minus 4, arbitrarily I am saying, now if we increase the temperature, now let's suppose its Kw value will have became 10 to the power minus 12. What does it mean? 10 to the power minus 14 is higher value, or 10 to the power minus 12 is higher value? 10 to the power minus 12 is higher value, right? Then if 10 to the power minus 14 means H plus ion concentration is 10 to the power minus 7, then its pH will be 7. Then if the Kw is 10 to the power minus 12, then H plus ion concentration will be 10 to the power minus 6, right? Then the pH will be 6. Compared to the pH, what happens? If the Kw value, it depends upon the temperature, right? As the temperature increases, Kw increases. Arbitrarily, let's suppose it has been at 80 degree, Kw is 10 to the power minus 2 means then H plus ion concentration will become 10 to the power minus 6. Why? Kw is equal to concentration of H plus and concentration of OH minus. Then Kw value will be the 10 to the power minus 2. When will become this 10 to the power minus 2? If the 10 to the power minus 6, and this should be the 10 to the power minus 6. Kw will be increases, then obviously the pH will be decreases, right? Is it clear? Is it clear? Answer is A. Right. Next question. Next question. Good, everyone, good. Now next question. When the hydrogen ion concentration changes by the factor of 1000, the value of the pH solution. The value of the pH solution. The value of the pH solution. When the hydrogen ion concentration changes by a factor of 1000, the value of the pH of the solution. The value of the pH of the solution. Good evening, everyone. Answer is C. Yes. Now, pH is equal to minus log of H plus ion concentration, right? Now, if you dilute this H plus ion concentration by 1000, means its pH value, let's suppose before it is a 4, then you have diluted by the 10 to the power or by the 1000 units, then its pH will be decreases, then it will become pH will be decreases, or H plus ion concentration will be decreases to the 10 to the power minus 7. Before the 10 to the power minus 7 molar H plus ion concentration, pH is 4. Then after diluting by the 1000 units, H plus ion concentration has become 10 to the power minus 7. Then pH will become 7. Means how many times the pH has been decreased? 3 times, right? Decreases by 3 units. Decreases by 3 units. Good evening, everyone. Good evening. Decreases by 3 units. I hope it is clear. Done. Right. Next. This is a very interesting question and the buffer question. Now try to answer. Don't be in hurry to give the answer. Check the calculation part also. Check the calculation part also. A class 12th students were asked to prepare the 1 liter of buffer solution of pH 8.2 by their chemistry teacher. The amount of ammonium chloride to be dissolved by the student in 0.2 molar of ammonia solution to make 1 liter of buffer is. So he is asking the amount of ammonium chloride. He is asking the amount of ammonium chloride. Chai trail something. My dear friends, this is somewhat lengthy calculation. Okay, this lengthy calculation already I have said very clearly, don't use the phone. First of all, if you know the answer, don't use the phone. Try to do the calculation by your own, because in your exam they will not allow you any gadgets for the calculation purpose. If you don't know, give me the question mark, but don't see in any chat GPT or any Google or somewhere, because this one will give you somewhat lengthy calculation. Somewhat calculation part will be there, but chai trail is saying very fastly. Okay, now may I know who is this? Okay, fine, good. Already this is a previous year JEE question. Okay, good. Okay, good evening everyone. Now see, now he is asking the buffer solution, right? Now this is a amount of ammonia chloride is asking. The amount of ammonia chloride is asking, right? This is a base, right? Basic buffer. pH is equal to pKb plus log salt concentration by base concentration. This is a basic buffer formula we know, right? Now here already pH they have given. pH is equal to pH plus pOH is equal to 14. Now pH they have given, then it will pOH will become 14 minus 8.26. 14 minus 8.26, how much it will give you? 14 minus 8.26, it will give you approx 5.76. then it will give you the pKb already they have given 4.74 plus log, then he is asking the amount, means this concentration, this is a concentration, right? So we don't know, we have taking it as a x by base concentration 0.2 they have given. Then if you shift this 4.7 to the left hand side, 5.76 minus 4.74 equal to log x by 0.2. then this entire value after the solving, this x value you will get it as 2. This x value you will get it as 2, right? Then this x is nothing but concentration of the salt, right? This is a concentration of the salt. Concentration is nothing but molarity. Molarity is equal to n by concentration already 1 liter, right? N by V. So molarity is directly proportional to the n formula will be amount, weight by molecular weight. Molecular weight is 53.5. so 2 into 53.5 is equal to amount added in grams. So that will be the 107. I hope it is clear. I hope it is clear for everyone. I hope it is clear. Right, answer is C. Good. Now for a given solution, the pH is 6.9 at 60 degree. Now Kw is 10 to the power minus 12. The solution is for a given solution, pH is equal to 6.9 at 60 degrees Celsius, where Kw is 10 to the power minus 12. The solution is acidic, basic, neutral, unpredictable. Don't be in hurry to give the answers. Once again I am explaining very clearly for you. Don't give the answers very fastly without thinking. Just see over there. Don't give the answer by seeing the pH. Try to think. Don't be in a hurry to give the answer. Now the answer is basic. It is not the acidic. See, my dear friends, here Kw already I have explained very clearly. At 25 degrees Celsius, experimentally Kw value will be 10 to the power minus 40. Now it is not 25 degrees Celsius. You have given the 60 degrees Celsius. At 60 degree, temperature increases, right? Temperature increases means Kw value also should be increased. Now the Kw value has been increased to the 10 to the power minus 12, right? 10 to the power minus 12 means compared to the 10 to the power minus 14, 10 to the power minus 12 is higher. Then it's a resultant neutral solution, Kw 10 to the power minus 12. Then the H plus ion concentration and the OH minus ion concentration will be the 10 to the power minus 6 and the 10 to the power minus 6. Then the pH scale will be up to 0 to 12. Then the neutral will be 6. Then 0 to 6 is the acidic and 6 to 12 will be the basic. Then the resultant given solution pH, they found that it is a 6.9. 6.9 means the resultant solution will become, then the resultant solution will become basic, right? Simple answer. The resultant solution will become basic. How come acidic? Don't see the direct pH. Now see the Kw value also. At 10 to the power minus 14 at 25 degrees Celsius only, that pH will be the 6.9, that it is acidic. But now the Kw value is 10 to the power minus 12, means now the pH scale will be up to 12 only. It will become shrink, right? So the answer is B, not A. Don't get confused. Right? No. Next one. Which of the following compound cannot act as Lewis base? Which of the following compound cannot act as Lewis base? Which of the following compound cannot act as Lewis base? D. Good, good, good. Still anyone? Good. Yes, yes. Good. Right. Now, what is the meaning of the Lewis base? Electron pair donor. Electron pair donor is the Lewis base. Electron pair donor is a Lewis base. Right? Clear? How it is 6? See, if you want the at 10 to the power minus 12 Kw, if you want the H plus ion concentration, if you take this as a X and the X, now H plus ion concentration will be equal to OH minus ion concentration. Then it will become X square, right? X square is equal to 10 to the power minus 12. X is equal to 10 to the power minus 6. Then Kw, if it is 10 to the power minus 12, then its H plus ion concentration and the OH minus ion concentration will be the 10 to the power minus 6 and the 10 to the power minus 6. Then the pH scale will be up to 0 to 12 and the neutral, when the solution will become 10 to the power minus 6 and the 10 to the power minus 6. Then the resultant pH is 6. Then neutral solution for the Kw 10 to the power minus 12 is 6, means neutral solution if it is 6, then the final solution it will be the 12, acid 12 to 0 to 12 will be the pH scale. Now electron pair donor is a Lewis base. Now here the SF6, one lone pair will be there for the SF6, sorry SF4, SF4, one lone pair will be there. Due to this lone pair it can donate. Now NF3, one lone pair will be there, it can donate. Now ClF3, it is having the two lone pairs, so it can donate. But the PCl5, there is no lone pair and it is having the vacant orbital which can accept the electrons, into its empty orbital. So it is acting as a Lewis acid, not the Lewis base. Right, next question. Now for a monoprotic acid, 0.1 molar aqueous solution ionizes to 0.01%. The ionization constant Ka is. This is very simple question. Don't be in a hurry. Ionization constant. What is the answer? What is the answer? If you don't know, give me the question mark. I'm ready to explain. Are you trying or not? Are you there? B. It is 10 to the power minus 6. Yes, good. Now, monoprotic acid of 0.1 molar aqueous solution. So the monoprotic acid, it is a HA. It will donate the 1 proton. Clear? Done. When it has donated 1 proton, H plus and A minus. Now, is what is asking? Ionization constant is asking. So its a molar concentration is 0.1. Initially 0, 0. Then we know, right, basic C 0, 0. C into 1 minus alpha, C alpha, C alpha. Right? Now the ionization constant Ka is equal to, what is asking? The monoprotic acid 0.1 molar aqueous solution ionizes to 0.01%. The Ka ionization constant. The ionization constant will be the C into alpha. C into alpha. Right? Now here of monoprotic acid means we have to see on the basis of H plus ion concentration. H plus ion concentration into C into alpha. Right? C concentration what we are having? 0.1. Then alpha dissociation, how much it has happened? 0.001 by 100, because it is a percentage, right? So concentration of the acid is 0.1 into 0.001 by 100. Then if you multiply and if you solve this one, you will get the answer B. 1 into 10 to the power minus 6 you will get. Good everyone, good. 1 into 10 to the power minus 6 you will get. Clear? I hope it is clear, or still you are having. Right? No, next question. What is asking? Arrange the following solution in the decreasing order of pH. In the decreasing order of pH. The decreasing order of pH is asking. Arrange the following in the decreasing order of pH. Arrange the following in the decreasing order of the pH. What is the answer? Decreasing order of pOH. Decreasing order of POH. Are you trying or not? Answer is B. Wow. See, is asking POH, right? This is acid they have given, first one. Acid we have to represent it on the basis of pH. pH is equal to minus log of H plus ion concentration, that it is a 10 to the power minus 2. Then its pH will be the 2. Then its POH will be 12, because pH plus POH is equal to 14. We know pH is 2 means POH will be 12. So its POH will be the 12. Then this is a base. Already it is a base. NaOH is a base. Then we can represent on the basis of POH. POH will be equal to minus log of 10 to the power minus 2. Then its direct POH will be the 2. Clear? It's a direct POH will be the 2. Next one. Next, 0.01 molar of acetic acid, right? Then here, next one, this is a 0.01 molar of the NaCl. NaCl, this is a salt. This is a salt of strong acid plus a strong base. Strong acid versus strong base salt, pH will be equal to 7. Then its POH will be equal to 7. Right? Then option C, this is sodium acetate. Sodium acetate is a salt of weak acid plus a strong base. Weak acid plus strong base, pH will be greater than 7. pH will be greater than 7. Then its POH will be less than 7. POH will be less than 7, but not less than 2. It will be somewhat less than 7, but it is not less than 7. Then according to this one, highest pH will be for the A. Then after that, the highest POH will be for the which one? D. Then it will be for the C, and the last will be the B. The answer is B. Answer is B. I hope it is clear. I hope it is clear for everyone. Right. Next one. Total number of diprotic acid among the following. Total number of diprotic acid among the following. Total number of diprotic acid. Total number of diprotic acid. Total number of diprotic acid. Answer. How many? Integer type question. How many diprotic are there? How many diprotic acids are there? Total number of diprotic acid among the following. Total number of diprotic acid among the following. Total number of diprotic acid among the following. Are you there? Are you trying or not? If you are trying, say me yes. If not, give me the question mark. I am ready to explain. Diprotic means 2H plus donors. Diprotic is nothing but 2H plus donor. Diprotic is this is NEET question only. This is your previous year NEET question, but just I removed the options. This is your previous year, not previous year. This is somewhat NEET question only, but I just removed the options. Diprotic is nothing but the acid which donate the 2H plus ions. See, HCl is a monoprotic, means it will donate the 1H plus. Now H2SO4 is a diprotic because it will donate the 2 protons. That's the reason if any H3PO4 is a triprotic, it will donate the 3 protons. Clear? Monoprotic means single donor. Diprotic means 2H plus ion donors. Triprotic means 3H plus ion donors. That's it. But answer 5 is wrong. Now listen. What are those acids are the dibasic? Now listen. First one, H3PO4. H3PO4 is a triprotic. It is not the di. So option 1 is wrong. So H2SO4 is a diprotic. We know. H3PO4, its oxyacid structure will be in this manner, right? This is the H3PO4 and it can donate the 2H plus. So H3PO4 is a diprotic. Now carbonic acid also it can donate the 2H plus. Then H2S2O7, its oxyacid structure will be the H2S2O7. Now this is a H2S2O7. Now in its oxyacid structure, the number of OH groups are there, that many protons it can donate. So this one also it can donate the 2 proton. Next, this is a boric acid. Boric acid is only the monoprotic acid. It will not donate the 2. Now next one, H3PO2. H3PO2 is a only monoprotic acid. It is a monoprotic acid. It can donate only 1 proton. Now H2CrO4, it can donate 2 proton. Now H2SO3, it can donate the 2 proton. So 1, 2, 3, 4, 5, 6. Now this is a H2SO3 structure. So H2SO4, H3PO3, H2CO3, H2S2O7 and H2CrO4, H2SO3. These are the what? These are the diprotic acids. So the answer is 6. Clear? Next one. Now the acidic buffer is obtained by. Is asking how the acidic buffer is obtained. Acidic buffer is obtained by. Acidic buffer is obtained by. What is the answer? Acidic buffer is obtained by D. Now we'll see. What is the meaning of the acidic buffer? How the acidic buffer will be formed? Acidic buffer will be formed by the weak acid plus salt of weak acid plus a strong base. Or else ORR. Now weak acid plus salt of its conjugate base, salt of its conjugate base, right? In this manner the buffer will be formed. Then first one we'll see. First one, if you cross check 100 ml of 0.1 HCl. Now already this is a CH3COO Na. This is a salt of which one? Weak acid plus a strong base salt, and HCl is there, but it should be the weak acid. Salt that should be formed from that, but here we are having the strong acid, so this option is wrong, right? Then 100 ml of HCl and 100 ml of NaCl, so it will not form. Option B is also wrong. Then if you go it for the option D, then CH3COOH plus NaOH gives rise to CH3COO plus H2O, right? Now here the 100 into 0.1, how much? 100 into 0.1. Now it will give you the 10 molar concentration of the acetic acid. Then 200 into 0.1, it will give you the 20 molar concentration. Means acetic acid is a LR. Acetic acid is LR, means completely it will be converted into the products. Then here the 10 molar will be there. But what it should be there? Took the acidic buffer to the form. Acidic buffer to form weak acid plus salt of weak acid plus a strong base, it should be there. But we are having the strong base plus salt of its weak acid plus strong base. So this is not the buffer. Then when it comes to this one, here it is a 10 moles and here it will also the 10 moles. Here also it will be the 100 into 0.1, it will be the 10. Now here also 10. Then here there is no any buffer, then it will become CH3COOH Na. Then I hope somewhere here also acidic buffer will not form. Then we'll see about this one, HCl plus NaCl, it will not form. Then if you see the option 1 also, there is no any options. Acetic acid plus NaOH, this should be formed, but this may be 0.2 actually. This may be the 0.2 option. Then it will form the acidic buffer. 100 into 0.2 will form the 20. Then it will become, this one will become 10. Then acetic acid 10 and this one will be the 10. So option C. Actually this is 0.2. Option C. Option D will not form. Option D there is no chance. We are having the weak strong base and a salt of its own. I hope it is clear. I hope it is clear. I hope it is clear, or still you are having any confusion. Done. Can I move? Can I move to the next question? Right. Now, for an acidic solution, the OH minus ion concentration is for an acidic solution, the OH minus ion concentration is, for an acidic ion solution, the OH minus ion concentration is, for an acidic solution, the OH minus ion concentration is, the OH minus ion concentration is OH minus ion concentration. See here, H plus ion concentration and OH minus ion concentration will be equal to Kw, that it will be the 10 to the power minus 14. 10 to the power minus 14, right? here acidic solution is say. Acidic solution means H plus ion concentration should be more than the OH minus ion concentration, right? Acidic solution should be nothing but H plus ion concentration should be more than the OH minus ion concentration, then the solution is acidic, right? Yet neutral solution, this is 10 to the power minus 7 molar, this is 10 to the power minus 7 molar, neutral solution. Then when we can say this as a acidic solution? When the H plus ion concentration is I. When the H plus ion concentration is I, then OH minus ion concentration should be less. Then OH minus ion concentration should be what? Less than 10 to the power minus 7. It should be the less than 10 to the power minus 7. Means here the H plus ion concentration should be high. How? It will be the OH minus. Now when the H plus ion concentration is I, then H plus ion concentration is I when we say the solution is acidic. If the solution is acidic, H plus ion concentration will be more. H plus ion concentrations will be more. If the H plus ion concentration will be more means OH minus ion concentration should be less. That it will be the less than 10 to the power minus 7. That it will be the less than 10 to the power minus 7. Clear? I hope it is clear. I hope it is clear. Should I move to the next question? Conjugate base for the Bronsted acid of H2O and HF. Conjugate base for the Bronsted acids of H2O and HF. H2O and HF. For the H2O and HF, what is the answer? Right. Now what is the answer? What is the answer for this question? What are the conjugate bases for the Bronsted acids of H2 and HF? Answer is A. Good. Now the H2O, by the loss of one H plus, it will become the Bronsted base, that is a O minus. For the HF, by the loss of H plus, it will become the F minus. So the answer is A. No, this H3O plus is the conjugate acid of the H2O. No. H2O conjugate acid means accepting of H plus. If it is accepted the H plus, it will become H3O plus. No, HF, it is not having any chance to accept the H plus. Right, the answer is A. Good. Next one. Ionic product of the water will be increases if. Ionic product of the water will be increases if. Ionic product of the water 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 will increases if. What happened, ma? What is the answer? Ionic product of the water will increases if ionic product of water will increases if D. Good. Ionic product means nothing but Kw, right? Ionic product means Kw. Ionic product is nothing but Kw. Kw will be concentration of H plus and the OH minus. Then ionic product of the water Kw is increases with the increasing in temperature. As we increases the temperature, ionic product of the water will also increase. Right. Next one. 0.01 molar acetic acid solution 1% ionized. The pH of the acetic acid solution will be 0.01 molar acetic acid solution is 1% ionized. The pH of the acetic acid solution will be pH of the acetic acid solution will be pH of acetic acid solution will be B. No, not B. See, acetic acid, right? How the acetic acid will be dissociate CH3 COOH. Now it will be dissociate as the acetate ion plus H plus. Then its concentration is 0 0. Now C into 1 minus alpha C alpha C alpha. Now we need the concentration of the H plus to know the pH of the solution. pH will be equal to the minus log of H plus ion concentration, right? Right. Now the acetic acid solution H plus ion concentration, if we know the pH. Then here the concentration of the acetic acid is 0.01 and ionization is 1%, right? Ionization is 1%, means 1 by 100. Then how much it will become? It will become 10 to the power minus 4, right? 10 to the power minus 4. Then if it has become the 10 to the power minus 4, the pH will be equal to 4, right? You have to be very careful. 1%. 1% means 1 by 100. Percentage. It will be the 1 by 100. 1 by 100 will be the 10 to the power minus 4. Minus log of H plus ion concentration is 10 to the power minus 4. Then the pH will become 4. pH will become 4. I hope it is clear. It is not 3. It is 4. It is not 3. It is 4. Okay. Right. Next one. Conjugate base of OH is conjugate base of OH minus is asking the conjugate base of OH minus ion. Conjugate base of OH minus ion. Conjugate base of OH minus ion. What is the conjugate base of OH minus ion? What is the conjugate base of OH minus ion? D. Good. Now conjugate base is nothing but removal of the H plus ion. Now after the removal of the H plus ion, now hydrogen has lost with the H plus, means hydrogen it has lost with the electron. That electron, whatever the hydrogen has lost the electron, it should be gained by the oxygen. So it will become O minus 2. Answer D. Answer is D. Right. Now next one. Good. He is asking acidic, basic, amphoteric oxides respectively. Acidic, basic and amphoteric oxides respectively. Acidic, basic and amphoteric oxides respectively. What is the answer? Acidic oxide, basic oxide and amphoteric oxide respectively are acidic oxides, basic oxides and amphoteric oxide respectively are acidic oxide, basic oxide, amphoteric oxide respectively are. What is the answer? Are you there? Are you trying the question or not? Hello? Are you trying or not? Are you there? See, simple question. The acidic, basic and the amphoteric oxides respectively are. Acidic oxide, basic oxide and amphoteric oxide respectively are. Good. See, N2O3 is a acidic oxide and lithium oxide is a basic and Al2O3 is a amphoteric. Respectively is asking, right? So answer is D. No, this is a basic oxide. This is a acidic and this is a amphoteric, but is asking respectively. Acidic, basic and amphoteric respectively. Truth 3 should be. So D. Acidic, basic and amphoteric. So option D is correct. Option D is correct. Next. This is one good question. Now see the question carefully. The pH of the solution containing 50 ml of each 0.10 molar sodium acetate and 0.01 acetic acid. pKa is 4.74. He is asking the pH. He is asking the pH. Now say me the answer. What is the resultant pH of the question? What is the resultant pH? What is the resultant pH? pH of solution containing 50 ml of each 50 ml of each. Mm-hmm. 50 ml of each. What is the answer? If you don't know, say me, give me the question mark. I'm ready to explain. pH of the solution containing 50 ml of each 0.10 molar sodium acetate and 0.01 molar acetic acid pKa. Answer is A. Answer is D. No. See, sodium acetate and the acetic acid. Sodium acetate and the acetic acid will form the acidic buffer, right? Acidic buffer formula will be pH is equal to pKa plus log salt concentration. Salt concentration is how much? 0.10. Then base concentration and acid concentration. Acid concentration will be the 0.10. that is 0.01, sorry, that is 0.01, 0.01. Then pH is equal to pK already they have given. pK already how much they have given? 4.75. Then log 0.10 by 0.01 will be the log 10. Log 10 will be the 1. Then that it will be the 5.57. Simple. Answer A. 0.10 by 0.01 will be the 10. Log 10 will be the 1. 4.57 plus 1 will give you the 5.75. See, sodium acetate. Sodium acetate is CH3COONA. And acetic acid. Acetic acid is CH3COOH. So this two will form the acidic buffer, right? Weak acid plus salt of its. Now, clear? Done? My dear, someone is asking how much rank you got it in the JEE and NEET. My dear friend, I did not wrote any JEE and NEET. I wrote IIT JEE, I qualified, then I did MSc chemistry, then after that I did the PhD, which it is running. Clear? I hope it is enough for you. IIT JEE I have cleared, and the CSIR net, which is the highest ranking for the chemistry for the PhD, that is a state national wide exam. I cleared the JRF and I am doing the PhD. I hope it is clear. Done. If any doubts, if you are having, you can ask, I will clear. Done. Next question. Acidic buffer is obtained by the mixture of the same question, I think so. Acidic buffer is obtained by the mixture of the same question just now we have seen. Acetic acid plus 0.1 acetic acid plus now try to do the answer. Same question, same model of the question just now we have did. 100 ml of 0.1 molar acetic acid plus 100 ml of 0.1 molar NaOH. 100 ml of 0.1 molar HCl plus 200 ml of 0.1 molar NaCl. Now 100 ml of 0.1 molar HCl plus 200 ml of 0.1 molar sodium acetate. 100 ml of 0.1 molar answer A. Now 100 ml of 0.1 molar acetic acid plus 0.1 molar NaOH. Then it will give you the 100 into 1 by 10, it will give you the 10 molars and the 10 molar. There is no any LR. The completely it will be converted. A will not give. It will give you the A will give you buffer. Sorry, A will give you salt hydrolysis, not the buffer. Then if you take the HCl plus NaCl, HCl plus NaCl, it will not form the buffer. Then 100 ml of HCl means 10 molar plus sodium acetate. Sodium acetate, what it will form? Sodium acetate, it is a how much? 20 molars. Then 20 molar and this is a 10. Then it will be formed the acetic acid CH3COOH plus and it will become the NaCl and it will form the 10. This will become 0 and this will become the 10. Acetic acid is there and the sodium acetate is there, and this is the option C is correct. Option C is correct. Then if you cross check the D, acetic acid is 0.1, right? 1 by 10. Then it will become the 10 molars and NaOH will become 20 molars. So acetic acid will be the LR. So there is no any acetic acid, only the sodium acetate will be there. So option C is correct, because sodium acetate is 20 and HCl 0.1 molar HCl is 10. Then if it is reacted, it will form the acetic acid, because HCl is a LR. HCl is a LR, right? LR means it will become 0. It will become 0. Now we can see here we are having the acetic acid of 10 and the sodium acetate is of the 10. Then it will be the LR. From the 1 it is required, for the 10 it is required. Leftover will be the 10, right? Now the option C is correct. Option C is correct, because to form the acidic buffer, it should be have the weak acid plus salt of weak acid plus strong base, right? So just he made the question reverse. Nothing he made. Just to make you confused, he made the question reversed. I hope it is clear. I hope it is clear. Right. Next one. Acidic buffer is prepared by the mixture of weak acid is there, right? Here weak acid is there na, 10 moles. 10 moles of weak acid it is there, right? Why you are getting confusion? Option 3. Option 3, weak acid it is there. See, option C, HCl it is there. HCl moles how many? It will become 10 moles plus sodium acetate. Sodium acetate moles how many? 20. So, that's what I am saying. For the 1 mole of HCl require 1 mole of sodium acetate. These two will react to give the acetic acid. Acetic acid, right? Plus NaCl it will give. Done? Now, here HCl will be dissociated as the H plus and the Cl minus. Now, sodium acetate will be dissociated as the CH3COO minus plus NaCl, right? NaCl resultant solution will be the pH. It is a neutral salt. This is a neutral salt. So no any role of the pH will be there. Now these two will react, acetate ion and the H plus. Then it will form the acetic acid. Now you see this HCl is a LR. For 1 mole 1 required. For the 10 mole 10 required. We are having the 20 moles of salt, right? Now this LR means it will become 0. It will become 0. So as per the LR, acetic acid will form how much? 10 will form. It will form 10. Then how much acetate ion before it is a 20? Before it is a 20. From that one, after reacting with the HCl, it will become the 10 moles. 10 moles will be the left at the reactant side. This is 10 moles left at the reactant side and the 10 moles formed at the product side. So this is a weak acid and this is a salt of weak acid plus strong base, right? Both are there in the solution. These two combines will form the acidic buffer. I hope it is clear. These two combines will form the acidic buffer. HCl is a weak. No, HCl is not the weak acid. After reacting with the HCl, leftover solution we have to cross check. After the reacting, the solution will be there, right? See, after reacting, there is no any HCl only, because HCl is LR. See, after the reacting, the solution contain one neutral salt. See, one salt and the base only. I hope it is clear. I hope it is clear. See, after the reacting, there is no HCl and the HCl in the solution only. The solution contains sodium acetate and the acetic acid. I hope it is clear, or still you are having confusion. Clear or not? Should I move to the next question? Should I move to the next question? Should I move to the next question or not? Is it clear or not? Right. Now, next one. Acidic buffer is prepared by the mixing. An acidic buffer is prepared by mixing. Right. An acidic buffer is prepared by the mixing. Acidic buffer is prepared by the mixing. What is the answer? Acidic buffer is prepared by the mixing. Option A. Good, good, good. Option A. Acidic buffer is formed by the mixing of weak acid plus salt of weak acid plus strong base. Answer A. Right, right. This is a one beautiful question. pH of the solution is 6 in the solution. pH of the solution is 6 in this solution. Then what is the answer? Then what is the answer? Answer is A. Yes. Now you see, pH of the solution is 6. Then pH plus pOH is equal to 14. If the pH is 6, pOH will become 8, right? 8. Then pH contain H plus ion concentration. H plus ion concentration will be the 10 to the power minus 6. Then pH of the solution contain H plus ion concentration 10 to the power minus 6. Then 10 to the power minus 6 into 100 of H plus OH minus ion concentration. OH minus ion concentration will be 10 to the power minus 8. Then it will give you the 10 to the power minus 6 only, right? So H plus ion concentration will be equal to 100 of OH minus ion concentration. 100 of OH minus ion concentration. Good evening, Murli Karthik. Good evening. But this is not for you. This is for the juniors. This is not for the seniors. Right. Next. Simple question. Solubility product question. This is a solubility product question. If the solubility of PbBr2 is S gram per molecules per liter, considered 100% ionization, its solubility product is. Its solubility product is. Its solubility product is. Answer is C. Yes. PbBr2. Now it's sparingly soluble salt. It will be dissociated as a Pb plus 2 plus 2 Br minus. Then it will be the S and this will be the 2S. Then the Ksp will be equal to the S into 2S whole power 2. Then it will become S into 4S square. Then it will become 4S cube. So answer is C. Right? Answer is C. Good, good, good. Now, this is also one good question. A student needs to prepare a buffer solution of propanoic acid and its sodium salt with pH 4. The ratio of The ratio of propanoic acid, clear, the ratio of CH3CH2COO minus by propanoic acid requires to make the buffer is Ka they have given. Now what is the answer? This is also one interesting question. Nearest integer answer you give me. Okay, try to do it by your own and give me the nearest answer. What is the answer? What is the answer? Answer is C. No, this is integer type. Nearest integer is asking. Nearest integer. Nearest integer you say me in the form of in the 10 to the power minus 2. Okay, that nearest integer you say me the answer in the form of 10 to the power minus 2. You say me the answer in the form of 10 to the power minus 2. Ten to the power minus 2. What happened? Are you doing or not? Are you trying or not? Are you trying or not? Should I explain? Should I explain? Now see, now here it is forming the acidic buffer. Acidic buffer formula pH is equal to pKa plus log salt concentration, that it is CH3CH2 by CH3CO minus by CH3CH2COOH. Clear? Now the pH will be the 4, right? Now pKa, this is Ka they have given. pKa is equal to minus log of Ka. Minus log of Ka is 1.3 into 10 to the power minus 5. Then it will become 5 minus 1.3. 5 minus log 1.3. 5 minus log 1.3 plus log of ratio is asking. Ratio of this one. Ratio of this one. Ratio of this one is asking. Then 5 if you send it to the total, if you send it to the left hand side, then how much it will become? Log acetate ion concentration, sorry, propanate ion concentration by propanoic acid. Then how much it will become? Now log 1.3. Log 1.3. 5 minus log 1.3. How much it will become? 5 minus log 1.3. If you send it to the left hand side, it will become, how much it will become? 5 minus log 1.3. It will become 0.0 minus 5. It will become 4.88. 4.88. 4.88 approx we can take it as a 1. Nearly we can take it as 1 only. This one we can take it as nearly 0. So this one will become 1. 1 equal to log acetate ion concentration 5 minus log, it will become 4.88. It will become 0.88, I think so. 4.8, 4.8. Then 4.8 minus 4. 4.8 minus equal to 4. Then how much it will become? Okay, we'll try to do in this manner better. Instead of this one, we'll try in this manner. We are having the log, right? If you send it this one to the left hand side, then it will become log 1.3 minus 1, right? If I have sended this 5 minus log 1.3 to the left hand side, then it will become minus 5 plus 4 minus 1. Log 1.3 minus 1 is equal to log of this acetate ion concentration by this one. Log cancel. Log cancel. It will become 0.13. 0.13. So the acetate ion, the concentration of CH3CH2 COO minus by CH3 COO CH2 COOH will be equal to the 0.13, but is asking in the form of the 10 to the power minus 2, right? It will become 13. It will become 13. Clear? I hope it is clear. I hope it is clear. Will end. I will end now. One last question I will give you and I will end. Very simple question. What is asking? The solution pH close to 1. Which solution pH is close to 1 is asking. So 100 ml, sorry, 75 ml of m by 5 HCl plus 25 ml of m by 5 NaOH. B, 100 ml of m by 10 HCl plus 100 ml of m by 10 NaOH. C, 10 ml of m by 10 HCl plus 90 ml of m by 10 NaOH. D, 55 ml of m by 10 HCl plus 45 ml of m by 10 NaOH. Now say me the answer. Say me the answer. If he is asking nearest integer, it is a 0, but I'm asking in the form of 10 to the power minus 2. 10 to the power minus 2, right? So it will be the 13. What is the answer for this question? Solution pH close to 1. Which one? Solution pH close to 1 in which one? Solutions pH close to 1 in which one? Solutions pH close to the 1 in which one? Solutions pH close to the one in which one? Answer is A. Good. See, simple. What you have to do? H plus ion concentration is equal to N1V1 plus, then option yes, N1V1 N2V2. If you do, you will get the answer. N1V1 N2V2. If you do, you will get the answer. That will be approximately equal to the 1 you will get. Option A. Good. Fine. Right. By this, I'm ending the class up to here. Now, all the best for the tomorrow's exam. I'm ending the class. If you are having any doubts, you can ask me. If not, I will end the live. Anyone or having any concerns or any doubts, they can ask. Remaining, they can leave, or else if not, I will end the live. Option A. Yes. Option A. Okay, fine. Fine. Okay. Bye everyone. Good night. Good night. No doubts, right? Everyone? Okay, done.